In the last video, we informed you how the topic of metals rarely goes untested at K.C.S.E. Kindly join us in this second video where we take a journey through the testing patterns of the topic in chemistry paper 1, this time between the years 2018 and 2022. We begin with the year 2022, where question number 23 tested the metal iron. In part A, we are told that iron is extracted from hematite ore. Now, if the ore contains oxides of silicon and aluminium, we were asked to explain how these impurities are removed. And these impurities are simply removed by reacting with calcium oxide. Candidates, you remember, we react them with calcium oxide to form calcium silicate in the case of oxide of silicon, or calcium aluminate in the case of oxide of aluminium. Now, these calcium silicate and calcium aluminate are then removed as slag. So here, with that background information, the candidate was to answer that these impurities react with, I'll use symbols for our compounds so that we save on space. So they react with calcium oxide to form, again I'll use symbols for calcium silicate, and we have calcium aluminate. Those two, which are then removed as slag. So that is how we are able to remove the oxides of aluminium and silicon. It is 2 marks. So giving us the name of the substance that they react with is 1 whole mark. Formation of calcium silicate, half, and formation of calcium aluminate, another half. For part B, the extraction process of aluminium produces waste gases. State how these waste gases can be used to lower the operational cost of the extraction process. So here, the candidate was supposed to think of these waste gases being used to preheat the incoming air. And why are we able to use them to preheat the incoming air? They are of very high temperature. So the answer here is that the waste gases are of high temperature. They are of very high temperature. So what happens next is that the heat can be recycled. We then can recycle the heat and we use that heat to now preheat the incoming air. 1 mark, high temperature of the waste gases, half, and preheating the incoming air, another half. We proceed to now the year 2021, chemistry paper 1. Aluminium metal was tested as question number 21. Aluminium is extracted from aluminium oxide by electrolysis. Part A asked the candidate that other than the cost of electricity, the candidates were supposed to give Another reason why this method is expensive. Now, this method is expensive because the graphite anode has to be replaced periodically. So other than the cost of electricity, we also have to keep on buying these graphite anodes to be replaced, because we explained in our lessons that at the anode we usually produce oxygen, which reacts with this graphite, a form of carbon, to produce carbon 4 oxide. So they keep on reducing in size over and over again. For part B, the candidates were asked to calculate the mass of aluminium that would be obtained when a current of 20 amperes was used for 5 hours. The examiner went ahead to give the candidates 1 Faraday, 96,500 coulombs, and the relative atomic mass of aluminium as 27. So here, the first thing that a candidate would do is to write the equation for reduction of aluminium ions from the molten oxide to aluminium metal. Once we've written this equation, it is now time to interpret it. And as we always say, the number of moles of electrons involved in this equation coincides with the number of Faradays. So the meaning of this equation is that 3 moles of electrons would be equivalent to 3 Faradays. And this would be 3 multiplied by 96,500 coulombs. This would give us 1 mole of aluminium metal, which would have a mass of 27 grams. From here, after interpreting the equation, we would go back to our question and look at how much quantity of electricity were we given. So Q is given by current in amperes multiplied by time. Current is 20 amperes. Time is 5 hours, but it has to be expressed in seconds. So we multiply by 60 to convert into minutes, and another 60 to convert into seconds. This would give a total of 360,000 coulombs. From here, we would relate this quantity of electricity that we've gotten here to the interpretation of our equation. So how do we do so? We simply ask ourselves that if 3 Faradays are able to deposit 27 grams of aluminium, how about the amount of electricity that we passed through our electrolyte? How much are we going to deposit? So through cross multiplication, we get 360,000 multiplied by 27, and then we divide by 3 multiplied by 96,500. This, if we work out, we get a mass of 33.588 grams. It is worth 2 marks, so we shall give half for the replacement of the current from the question and conversion of time into seconds. The quantity of electricity in coulombs, another half. The working here, half, and the final answer, half, totaling 2 marks. Now that is 2021 K.C.S.E Chemistry Paper 1. And now we are supposed to proceed to 2020. But in the year 2020, in Chemistry Paper 1, the topic metals was never tested. So that would mean we proceed to the year 2019, where we are meeting copper this time round. The flow chart below represents some stages in the extraction of copper metal. The candidates were expected to use it, of course, after studying it, to answer the questions that would follow. So here, we start with copper ore. And as we know, copper ores are many. We have around 4 of them. At this point, candidate, let's simply take a look at the formulae of the various ores of copper. Let's start with copper pyrites. Copper pyrites is simply copper iron disulfide with that formula. Then we have malachite. Malachite has this formula here, and we call it basic copper carbonate. Then we have the next ore being chalcocite. Chalcocite is simply copper 1 sulfide. And then we have atacamine. Atacamine has the formula here. This formula would be simplified as basic copper chloride. So it is one of these ores that we have here. We are going to crush it into fine powder, and then it undergoes process B. Process B is now giving us a concentrated copper ore, which means process B helps in removing much of the unwanted materials in the ore. According to our discussions in class, this process must be froth flotation. From there, we roast our ore into air, and this is where we have a hint on which ore we used. We get copper 1 sulfide after roasting the ore, iron 2 oxide as well, and sulfur 4 oxide. Dear learner, we realize that this ore that we used at this point was actually copper pyrites. Why do we say so? We say so because when you roast copper pyrites in air, this is the equation for the reaction that occurs, and we are able to get the products that are indicated in this box. So we have copper 1 sulfide, we have iron 2 oxide, and we have sulfur 4 oxide. Of course, this equation is usually balanced with a 2 on sulfur 4 oxide, a 2 on iron 2 oxide, a 4 on oxygen, and a 2 on our ore. So from here, we realize that the copper ore that was used here wasn't malachite, it wasn't chalcocite, and it wasn't atacamite. It was actually copper pyrites. So once we do so, once we have roasted our ore in air, we introduce silicon 4 oxide. What silicon 4 oxide does is simply to remove our iron 2 oxide. Because sulfur 4 oxide, as we said earlier, is recovered and probably used in the contact process to produce sulfuric 6 acid. So, silicon 4 oxide would actually react with iron 2 oxide, and we get iron 2 silicate, which comes out as slag. So whatever we shall remain with here as solid C is now our copper 1 sulfide, having removed iron 2 oxide as slag and having recovered sulfur 4 oxide to be utilized in a nearby contact process plant. Now, having looked at the flowchart into detail like we've done, candidates, let's now go ahead and look at the questions that were asked. Part A, we were asked to identify Roman 1, the copper ore. And because we have studied our flowchart very well, you will agree with me that our ore was copper pyrites. That discussion has been very useful in helping us answer these questions. How about process B, froth flotation? And we are asked about solid C, which we have agreed is copper 1 sulfide. Having removed iron 2 oxide and having recovered the sulfur 4 oxide. So here half for the ore, half for the process, the ore is given 1 whole mark, half for the process and a half for our solid C. Next question asked us to write an equation for the reaction that forms slag. All these we have done in the discussion about the flowchart, and this will always be our advice to the candidates. Please, if you are given a flowchart, don't rush into the questions. Can you take time and study the flowchart into details? That would save you a lot of time in thinking about how to answer the questions. Probably all the questions that will be asked, you would have done them as you study the scheme. So the equation for formation of slag, we have just written it a few minutes ago. Silicon 4 oxide is reacting with iron 2 oxide, which we get after roasting our ore, and we get iron 2 silicate. Our slag, it balances out itself, so you don't have to for the last mark. Dear candidate, that does it for 2019 Chemistry Paper 1, question number 3, which tested copper metal. So we finally take you through the year 2018. In 2018, Chem Paper 2 tested iron. In Part A, we were asked to name at least 2 ores of iron for 1 mark. The chief ore is hematite. Then we have magnetite as well. A candidate would think of siderite being another ore of iron, and even iron pyrites. Any 2 for half mark each. Part B tested something on how to know the percentage composition of an ore of iron. So we were asked to describe how the amount of iron in a sample of iron 3 oxide can be determined. So this would involve quite a lot of processes. The first one being weighing. So we shall weigh our ore, weigh iron 3 oxide. Of course, we do so in a crucible. Okay? Then from here, once we've gotten the weight of our iron 2 oxide, we would want to reduce it using carbon. So we would then mix the ore, which in this case is iron 3 oxide, with, we are going to use coke or any form of carbon would do. From here, we shall heat the mixture. We heat the mixture, of course, of our ore with coke, and we are doing so to a constant mass. So which means we shall be heating, cooling, weighing, and we do so several times until we reach a constant mass. Once we have done that, once the constant mass has been achieved, we shall finally cool and then reweigh the residue, which in this case will be iron. So cool and reweigh the residue. Of course, in a crucible again. This crucible will have gotten its mass much earlier. So, the weight we shall obtain in procedure 1 and the one that we will have here, the difference in the two weights is going to give us the amount of iron in our ore. So we finally talk about the difference in the two weights. The difference in the two weights, or in the two masses, the difference in mass in the masses is the weight of iron in the sample that we are provided with. So it is 2 marks. We are going to have half mark for the first weighing, half mark for using the correct reducing agent, another half for the constant mass, and finally the difference in masses will earn ourselves the last half mark. Dear candidates, we have come to the end of our video.